Hi everyone, this is the second video for section 6.4 on ratios and proportions. So the second thing we're going to talk about is rates. So you may have heard the term rate when you've heard of ratios, and it's because a rate is a type of ratio. It's a ratio of two quantities that have different units. So we see this all the time. Really common examples are with mileage, where you compare the miles traveled to the gallons of fuel used, so miles per gallon. Also with speed, how many miles traveled compared to time, so miles per hour. And then conversions, when we convert inches to feet, centimeters to inches, or cups to gallons, or any other unit conversion that we may do. So we see these all the time, and they just come up a lot. So whenever you can notice, even when I just said this, whenever we had miles and then the fraction bar and then gallon, that I read this miles per gallon. So whenever we have any type of rate, we always read this fraction bar as per. So how many miles per gallon, miles per hour, things of that sort. And whenever we do anything with ratios, kind of like we said in the last video where we compared students to women, it's nice to keep the units, just so where it's all clear what you're dealing with and what you're talking about. And especially when we talk about rates, the units become really important, and then it can change the meaning of a problem if you don't put the units. I'm sure you've heard this in your math classes in middle and high school, that if you didn't have the units, you didn't answer the problem because you didn't put it in the context of what the problem was asking. So the same thing here. It's best to keep your units when you work with any ratio. Okay. So what we're going to do with rates is what's called unit analysis. And that is the process of changing from one unit of measure to another. And that's what we're going to do here in this example. So we have that a fast runner can run a mile in 4 minutes, and we want to know what's their speed in miles per hour. So how we do this? So the rate that we're given, we can write it as a ratio, and I'm going to choose to do this in fraction form. So we're given that the ratio is 1 mile over 4 minutes, and I'm going to abbreviate minutes as min. And we want to convert this to hours. How many miles per hour? So miles are already units that we want. So we're trying to convert miles per minute to miles per hour. So we want to change minutes to hours. And so the way that we do this is we use a multiplicative identity. So we're going to multiply by a multiplicative identity. And we're going to do that by saying, well, we know that there are 60 minutes in 1 hour. So that's our multiplicative identity, where 60 minutes and 1 hour are the same amount of time. So putting them as a fraction is just multiplying by 1. And so now we can multiply across. And one thing of how I wrote this, so we put our minutes diagonal from each other because we can cancel them out. Similarly to how most people, when they multiply this, they would cancel the 60 and the 4 to make it easier. I mean, you'll have to cancel it later. It's just canceling it before rather than after. These minutes will cancel because we're multiplying and dividing by them. So those are inverse operations. And so that means that those minutes will cancel. And so if we multiply straight across, we're going to get 60 miles over 4 hours. And we can take the units out and just do 60 over 4 miles per hour, which if we actually divide, we get 15 miles per hour. So if you can run a mile in 4 minutes, that means you're running at a speed of 15 miles an hour. Okay, so there's an example of a process that's similar to this in the book on the bottom of page 233 that is more detailed and more complicated, that is converting a yearly salary to an hourly salary. So if you want another example of how to do this unit analysis or unit conversion, you can look at that example in the book. That's a little bit more complicated. So there's really not that much to say on rates. The biggest thing is just this unit analysis and recognizing what a rate means in context. So there isn't that much more to say about it. So we're going to go ahead and transition to talking about proportions. So proportions are an equation stating that two rates or ratios are equivalent. So a ratio and a rate are just a value, right? We can write it as a fraction or with a colon or with the words, but it's just kind of a term. And then a proportion is an equation stating an equivalence of two of those terms. So one thing to note is that people sometimes use the word ratio and proportion interchangeably, but they're not the same. And it's all because of this equivalent condition right here. A proportion is an equivalence of ratios, whereas a ratio is just a relationship between those two quantities. But the proportions are equivalences of ratios. So they're not the same because a proportion compares ratios. Okay, so let's look at an example. So example, the same thing as before, where we had a recipe for a particular punch, where we had 1 part juice and to 1 part ginger ale. But we want to actually make this recipe now using this part-to-part relationship. So we have a 2-liter bottle of ginger ale and we want to use that whole bottle, and we want to know how much juice do we need to use if we use 2 liters of ginger ale. So this is a proportion. This is a proportion because it's an equivalence of 2 different ratios, where X is the amount of juice that we are solving for in this equation. It's an equation and you solve for a variable. So one thing that a lot of people would do at this point, and what a lot of people have been taught to do at this point, is to use the cross products property, or butterfly method, however you want to call it, where you say, okay, I want to multiply the top thing on one side and the bottom thing on the other side, and do the same thing the other way, the bottom thing and the top thing, and then you get a different equation. So change the equation of fractions to a different equation. And we can't do that, so that's C. Sorry about that. That C should be an X. Okay, so people would typically do this, but for this class, you cannot do this. So don't do this on your homework if you want to know how to do it correctly. So we're not going to do this just because, similarly to how I discussed the common algorithm for division, when dividing fractions, don't ask why, flip the second number and multiply. I'm not a big fan of this because it's too easy to lose what's going on if you use too many of these tricks. And a lot of times students will just memorize the tricks but not understand the concepts fully. So we want to minimize these tricks and write out all of the work. So that being said, if you're doing this on the exam that's coming up, you need to show this process the long way. And here is how I would want you to show that process. Okay, so we want to find the missing number in the proportion 20/3 equals X over 9. So how do we do that? Well, we can do it in different ways. So we've done something similar to this before, earlier in chapter 6. So we are looking at 20/3 is X over 9. So one way we can do this is to clear denominators, where we multiply both sides by a common denominator and then solve the equation that we get then. So I'm going to do that because 3 and 9, because 9 is a multiple of 3, we know that one of the common denominators here is 9. So I'm going to multiply by 9 on both sides. Okay, and then, well, I'm going to multiply 9 over 1. And then we multiply straight across. So we get 180 over 3 is 9x over 9. And the 9s cancel. I'm actually going to write this up on the next line. Anyway, we want, so this is 180 over 3 equals, the 9s cancel, so we can just write this as x, and then we divide, and we get 60 equals x. So if we were doing the cross products property, we would have gotten the same answer, but we would have missed these parts of the really important parts of this class. We would have missed that we multiply by a common factor here to solve this equation, right? These are the things that we're trying to get, is that we multiply by a common denominator. And then we would solve it this way. Okay, so this is how I would want to see you solve these problems, not using the cross products property. You should not do this in this course. And in general, like I said, not a big fan of tricks like these. Okay, so we're going to do a couple more examples to finish this out. That will be in the next video.